Hey YouTube, welcome to Higher Math Solutions. This week's tutorial is going to go over how to solve definite integrals using the fundamental theorem of calculus. This will not involve the u substitution examples, just regular formulas. All right. Definite integration is, you can think of it as displacement. So if I am trying to integrate a function from an interval from a to b, this is what we call a definite integral. And to solve this without using geometry or a calculator, I'm going to take the antiderivative of the function and I will find its displacement by first finding what the function is at the first number, which would be b, and then subtracting it from the second number, which will be a. A is your lower number and b is your higher number. Let's do some examples. Let's do the integral from 0 to 2 of 2x squared minus 6x plus 1. So all I'm going to do first is I'm going to use my power formulas and I'm going to take the antiderivative. The antiderivative of 2x squared, you add 1 to the power, and then I divide by that power. And then the next one I will add 1 to the power and then divide. And the antiderivative of 1 is x. Now if this was not a definite integral, you would put a plus c at the end, but for the definite integrals you do not. What we will do is I will put a vertical line and I will write my a and b down, and that tells me I am about to apply the FTC, otherwise known as the fundamental theorem of calculus. And what you do is you take the top number and you plug it into all of your x's. So I get 2 cubed is 8, minus 6 divided by 2 reduces to 3, so I'm going to go ahead and do that. And then when I plug in 2 squared is 4, and then plug in 2 in here. So that is me plugging 2 into every x in the function. And I'm going to do minus, and now I will plug 0 into every term in the function, which if I plug 0 in, I will get all my terms to be 0. And then you can start simplifying this some more. 2 times 8 is 16. Negative 12 plus 2 is negative 10. And I will leave my answer in that form right there. And that will be your answer. And it is a number, it is not an equation or a function. Okay, let's do another one. Let's do the antiderivative from 0 to pi over 3 of secant squared of x. So in this case, again, this is a definite integral because you have an a to b integral, so I will be getting a number. But what I'm going to do first is I'm going to take the antiderivative of secant squared, and that is one of your formulas, which that is tangent. But instead of putting a plus c, I will put the vertical bar and then do 0 to pi over 3. And then from here, you will apply the FTC. So plug pi over 3 in first, and then minus, then plug in 0. And then here you need to know your unit circle and being able to evaluate the trig function. Tangent of pi over 3 is square root of 3, and tangent of 0 is 0. And so my final answer is square root of 3. Let's do another one. Let's do the antiderivative from 1 to 2 of x plus 3x squared over square root of x. So this is a little bit harder antiderivative function. I'm not using u substitution for these examples, so what you need to do is figure out how to get this out of quotient form because you do not have any formulas for that form. In this case, you never want to keep radicals as radicals, you will rewrite them as powers. And then after that, I can divide out the x to the 1/2. So I have the antiderivative from 1 to 2, x over x to the 1/2, plus 3x squared over x to the 1/2. And then when you divide by the same base, you subtract the powers. So now I have the antiderivative from 1 to 2. 1 minus 1/2 is 1/2. 2 minus 1/2 is 1.5 or 3/2. Now you are actually ready to apply your power rule and take the actual antiderivative. So the antiderivative of x to the 1/2 is you add 1 to the power. And instead of dividing by the power, since it is a fraction, I'm going to go ahead and multiply by the reciprocal, so that way it is a little bit neater in the look of it. This next one, again, you're going to add 1 to the power, so that will be 5/2. But instead of dividing by 5/2, I will multiply by the reciprocal to make it look a little bit neater. And then I can apply the FTC, which means I plug 2 in first. So I'll have 2 to the 3/2 power, plus 3 times 2 is 6, so I'll go ahead and multiply the 3 and 2 here, and then I'll plug 2 into the power of 5/2. So that's the first part of FTC. And then minus, now you plug in the 1. Now 1 to the 3/2 is just 1, so I'm just going to write 2/3. And then 1 to the 5/2 is also 1, so I'll just write 6/5. And this is what I have right now. And then from here, you would just need to combine like terms, and or your teacher might let you stop here. But that is the calculus is finished at this point. And let's do one more trick. Let's do the antiderivative from pi over 4 to pi over 2. And let's do 3 sine of x minus cosine of x. So again, first I'm going to take the antiderivative. The antiderivative of sine is a negative cosine. And the antiderivative of cosine is a positive sine. And instead of putting the plus c, I will put the vertical line and put my a and b. Next step is the FTC. So plug pi over 2 into the function first. Make sure you plug it into both x's. And then minus, now plug in pi over 4. From here, you do need to remember your ratios to evaluate the trig. Cosine of pi over 2 is 0. And so sine of pi over 2 is just 1, so that one works out nicely. Cosine of pi over 4 is root 2 over 2. And sine of pi over 4 is also root 2 over 2. So here we have negative 3 root 2 minus 1 root 2, which gives us negative 4 root 2 over 2. This will reduce to 2 roots 2, so I have negative 1 minus a negative 2 root 2. And I will leave my answer just in that form right there. And that is the end of the problem. Thank you for watching Higher Math Solutions. See you next time.